Hello everybody, and already I told you how to find out the Laplace of a function. But today I am going to tell you how to find out inverse Laplace transformations. And already I have derived all the formulas. Okay, but very important point is that already I have told you how to use those formulas and without any confusion. Okay, so how to use it very easily. So what is the trick behind the formulas? That I have to tell you first. Then only you can do the problems. Okay, so see here. These are the some of the formulas. See. Listen, you should see the formulas clearly. So A by S square plus S square. Here S by S square plus S square. Here A by S square minus S square. Here S by S square minus S square. So in the denominator, there are two square terms. In the denominator, there are two square terms. One is A square, another is A square. Clear? One is the square of S, another is the square of A. And see, in the numerator, either S is present or A is present. Either S is present or A is present. Clear? Again, in the denominator, see, in between S square and A square, either minus sign is there or plus sign is there. And always remember, the variable is first and the constant is kept in the second. These are the tricks which you should remember in your mind. There are two terms in the denominator. One is variable square, another is constant square. Okay, and the variable should be written first and the constant should be written second. Okay, so either plus will be there or minus will be there. Then only I will tell you, after that I will tell you what is the difference. And either, that means there are two terms, one is the square of S, another is the square of A in the denominator. So either in the numerator, either you can write A or S, and it is compulsory. If it is not there, you should write. And I will tell you, okay, so if it is plus is there, then trigonometry function you should write sin 80 cos 80. Trigonometry functions. If minus is there, then you should write hyperbolic function. Okay, again, the very important point is that if A is there, then you should write sine. If in the numerator constant is there, then you should write sine. And if in the numerator variable is present, then you should write cos. Okay, so here, sine and cos. See here, if A is there, then you should write sine. If S is there, you should write cos. Here is A is there, so sine. S is there, cos. And plus is there, so sine 80 cos 80, trigonometric function. Minus is there, sine hyperbolic 80 cos hyperbolic 80. Clear? Similarly, here also the same form as I have derived in the previous class. Okay, so here same format, but S minus A and B are the two terms in the denominator. If in place of S I have written S minus A, that means you have to multiply e to the power t by fast shifting theorem. S shifting or fast shifting theorem. I have written S minus A in place of S. That means same result, but you should multiply e to the power t. But in place of constant, I have written B. Clear? Same format, either S minus A is there or B is there. That means square of S minus A or square of B is there. So in the numerator, either you should write B or you should write S minus A. You should. You may or may not. Don't think. You have to write either S minus A or B, so that you can put the format directly. Okay. So same format, if it is plus is there, then trigonometry function will be there. If minus will be there, then there will be, see here, if the minus is there, then you should write hyperbolic function. Okay, so same format, we are going to apply, and here 1 by s to the power n. See here, Laplace inverse of 1 by s to the power n is t to the power n minus 1 by n minus 1 factorial, and this one 1 by s to the power n minus n, 1 by s minus whole to the power n. It is t to the n minus 1 into e to the power t by n minus 1 factorial. That means Laplace inverse 1 by s to the power n. I have also derived this formula. It is t to the power n minus 1 by factorial of n minus 1. Clear? Again, Laplace inverse 1 by s minus a to the power n. That means in place of s I have written s minus a. So by pass shifting theorem, so same thing, but you should multiply e to the power 80. Clear? So now we have to do the problems. Okay. So see here, I have given some problems. I will prove these theorems. Okay. So see here. These are the problems which you should do. Okay. So see here, number 40 I am going to tell you. Or 39 now, as I have, first one, number 40. Laplace inverse 5s divided by s square minus 25. But you should move from denominator. Don't move from numerator to denominator. You should move from denominator to numerator. That means Laplace inverse always gives some space before Laplace inverse. Okay. So first write the denominator. It is s square minus 5 square. Okay. Then either in the numerator s will be present or 5 will be present. But s is already there. So take the 5 outside. Clear? So this is 5, and the formula is, I have told you, if s is present, it will be cos. And if minus is present, this is hyperbolic. Cos hyperbolic 5t. So this is the answer. Very simple. You have to remember the logic. After that you can do all the problems. So see here. Another question. Laplace inverse 2s plus 3 divided by s square plus 4. So how to do this type of problems? So you want to separate first of all 2s by this one plus 3 by this one. So let us separate. Laplace inverse 2s divided by s square plus 4, I am writing 2 square. Then plus Laplace inverse 3 divided by s square plus 2 square. Then see here, Laplace inverse. This one is, I have told you, you should write the denominator first, s square plus 2 square. In the numerator, s is already there, so take the 2 outside. Okay, now here, Laplace inverse s square plus 2 square. So there is no s in the numerator, so you should write 2. Okay, now take the 3 outside, and since I multiplied 2, I have to divide 2. Okay, so now 2 into, see here, s is there, so cos, plus is there, so trigonometry, cos 2t, plus 3 by 2, constant is there, so sine, and plus cos is there, so trigonometric function 2t. So this is the answer. Okay. Now, let us do another question. S minus 4 by S square minus 4. Laplace inverse S minus 4 by S square minus 4. So you have to separate it first. Laplace inverse S by S square minus 4, then minus Laplace inverse 4 by S square minus 4. Then you have to move from denominator S square minus 2 square. So in the numerator see whether S is there or not. S is there. So this part is already in the form. Now here Laplace inverse in the denominator you should have S square minus 2 square. So there is no S. That means you should place constant and constant should be 2. That means I am splitting 4 as 2 into 2. So I have to take another 2 outside. Okay. So this one is S is there. So cos. Minus is there. Hyperbolic 2t. Minus 2. Constant is there. So sine. Minus is there. Hyperbolic 2t. In a cool mind, you should remember the formula. Then only you can do the problems. Okay. So let us see. So this question see here. Not exactly I am doing this one. I am doing a different question, and so that these problems will be homework for you. 2s square plus x to the power 4 divided by x to the power 7. Already I have told you 1 by x to the power n. It is t to the power n minus 1 by factorial of n minus 1. Laplace inverse of 1 by s to the power n is t to the power n minus 1 divided by factorial of n minus 1. Okay. So see here. I am separating, I am taking 3 outside. Laplace inverse 1 by s to the power 7 plus I am taking 2 outside. S square s to the power 7 cancel and it will become 1 by s to the power 5 plus Laplace inverse s to the power 4 s to the power 7 cancel out. Remain 1 by s cube. Clear? Now 3 1 by s to the power 7 1 by s to the power n, it is t to the power n minus 1 by factorial of n minus 1. So here n is 7. So 7 minus 1 t to the power 6 by factorial of 6 plus 2. Here n is 5. So t to the power 4 by factorial of 4. Then plus Laplace inverse. Here n is 3. So t to the power 2 by factorial of 2. Sorry. Not Laplace inverse. It is t to the power 2 by factorial of 2. So now you can write the answer. After cancelling, you can write the answer. Okay. So let us do another question. See here, this one is very interesting question. Laplace inverse s by L square s square plus n square pi square. These questions are collected from different books. Clear? From different engineering books, from BSc books and from MSc books also. From different books I have collected. Okay. So see here, in all the formulas, the coefficient of s square was 1. coefficient of s square was 1. But here the coefficient of s square is L square. So you have to take common L square. So 1 by L square, take common. It will become Laplace inverse. Write the denominator first. It is s square. And the second one will be n square pi square by L square. I am taking common L square from the denominator. So it will become n square pi square by L square. That means n pi by L whole square. So either in the denominator s will be present or n pi by L will be present. But already s is there. Okay. So 1 by L square, write the formula. S is there. So cos. Plus is there. So trigonometry. AT is n pi by L into t. So this is the answer. Okay. So now, let us do another question. Laplace inverse minus s minus 10 divided by s square minus s minus 2. And just I am going to do this one in a very interesting way. Please see this problem, how I am doing. Factorize the denominator. It is s minus 2 into s plus 1 minus s minus 10. Then you have to do the partial fraction. And how I am doing the partial fraction, let us see. It is equal to Laplace inverse s minus 2 s plus 1. I am doing this problem directly. Listen mindfully. What is the trick behind it? S minus 2 equal to 0. S minus 2 equal to 0. S is equal to 2. Take s minus 2 equal to 0. So it will be s is equal to 2. Omit this one. Same factor. You should omit this factor. Then put s is equal to in the rest part. Put s is equal to in the rest part. S is equal to, that means minus 2 minus 10. It is minus 12. S is equal to 2 plus 1 3. So minus 12 by 3. It is minus 4. I am writing minus 4. Then s plus 1 equal to 0. S is equal to minus 1. So omit this one. Put s is equal to minus 1 in the rest part. S plus 1 equal to 0 means s is equal to minus 1. Omit this same factor, you should omit this one and put s is equal to minus 1 in the rest part. So minus of minus 1, it will be plus 1. So minus 10 plus 1, it is minus 9 divided by minus 1 minus 2, it is minus 3. Okay, so minus 1 is cancelled out. 9 by 3, it is 3. Clear? So, now you can do very easily. Separate it, just separate it. Laplace inverse minus 4 by, or it will be better, I am taking outside directly. Minus 4 I am taking outside. Laplace inverse 1 by s minus 2 plus 3 Laplace inverse 1 by s minus of minus 1. I can write like this. So which will be equal to minus 4. 1 by s minus a. Laplace inverse of 1 by s minus a. It is e to the power t. So here a is 2. E to the power 2t. Plus 3. This one is e to the power minus t. Because a is minus 1. So this is the answer. Okay. So now, the same process, I am now doing another question. Laplace inverse 6 by s minus 2, s plus 2 into s minus 4, s plus 2 into s minus 4. How to do the partial fraction? Again I am doing this one. S plus 2 plus s minus 4. So s plus 2 equal to 0. S is equal to minus 2. Omit this factor. Put s is equal to minus 2 in the rest part. So here minus 2 minus 6. Minus 2 minus 4 it is minus 6. 6 by minus 6 it is minus 1. Again s minus 4 equal to 0. S is equal to 4. Omit this part. Then put s is equal to 4. 4 plus 2 6. 6 by 6 it is 1. Now we are going to take minus outside. Laplace inverse 1 by s minus 1 minus 2 plus Laplace inverse 1 by s minus 4 minus this is e to the power minus 2t. It got a t. Here a is minus 2 plus and this one is e to the power 4t. So this one is the answer. Okay, so but you have to remember the formulas. Without remembering the formulas, you cannot do the problems. Okay, so another question, very interesting question I am going to tell you. Okay, let us see. Laplace inverse 2s cube divided by s to the power 4 minus 1. This problem I am going to solve in a very interesting way. See here. Laplace inverse. This one I am writing s square plus 1 s square minus 1 2s cube. Whatever logic I am applying, see here. S square plus 1 then s square minus 1. How I am doing this one, please listen carefully. What should be multiplied to this factor and what should be multiplied to this factor so that their sum will be 2s cube. आपको इस फैक्टर से कितना मल्टीप्लाई करना पड़ेगा, इस फैक्टर को से कितना मल्टीप्लाई करना पड़ेगा सो दैट उसको जब ऐड करेंगे उसका आंसर 2s क्यूब आना चाहिए. यहां पर कितना मल्टीप्लाई करना चाहिए, यहां पर कितना मल्टीप्लाई करना चाहिए इस फैक्टर से सो दैट उसका सम होगा 2s क्यूब. Even multiply s to this factor and s to this factor and then add. That means see here s cube plus s cube 2s cube. This is plus s, this is minus s, cancel out. What should be multiplied to this factor and what should be multiplied to this factor so that their sum will become 2s cube. Is that clear? See here. Now, the factor, the term which you are multiplying to this one, you should write here. Yes. And the term which was multiplied to this factor should be written here. Because while taking LCM, you are cross multiplying. You are simply cross multiplying. Okay. So now, I am writing directly the or say listen. Laplace inverse s by s square plus 1 plus Laplace inverse s by s square minus 1. And here 1 I can add 1 square, here also 1 I can add 1 square. S is present, so cos. Plus is there, so trigonometry function a is 1, so cos t. Plus, here s is present, so cos, but minus is there, so hyperbolic 80, that means 1. So this is the answer. So you should remember the different tricks which I am telling you. Okay, then only it will be very easy for you. Now, do these problems. Try yourself. In my next video, I will tell you some more problems so that it will become very easy for you because there are so much problems here and I will do all these problems. Okay, maximum problems I will do in the board and here see how many problems I have given. So I will do all these problems, I will tell you the tricks and in the description also I will upload these problems so that it will be very easy for you and I have also given the answers. Okay, so if there is any problem then you can ask me. Okay, so in my next video I will do some more problems, some more interesting problems. So till then, bye bye.